All right, hey guys, sorry that we can't do a live stream tonight, but hopefully this will be a good substitution. We're going to be reviewing Unit 7, which is all things trigs and unit circle. You can see that I'm sitting here between my two unit circles. That one's a dream catcher somebody made for me, and this one is one where they took crayons and like blow dried it all out. Two of my favorite things in the whole world because you guys know how I feel about trig. So hopefully by the end of this live stream or this video, that's how you will also feel about this unit. So if you're watching this later and you have questions, send them to me. Even though this isn't live, you guys are still welcome to send me questions. And we're going to run through the basics, and then I really want to dig in some more to graphing because that seems to be the area where we still have the most questions. So we're going to start by looking at angles that are drawn in standard position. So the idea when we draw angles in standard position is that, first of all, we know where the initial ray is. So typically in standard position, that means that it is going along the positive x-axis. And then we have a defined direction of rotation. If we are going counterclockwise, that's a positive rotation. If we are going clockwise, that is a negative rotation. And remember, we can remember that because we're going from quadrant 1 to 2 to 3 to 4 in a positive rotation. Now, all these questions that we're going to do tonight are actually from your review stations or your review sheet, so feel free to get that out and follow along as we go. But we're going to start by sketching some angles in standard position, stating the quadrant in which they lie, and then working on finding the reference angle for them. So let's start with 280. So the big thing I would remember here is that our quadrants are each 90 degrees. So 90, 180, 270, and then back at 360 or at 0. So 280 is going to be just past 270, right? Here's our initial side, and then this would rotate all the way around to there. So my terminal side is in quadrant 4. And then what is the reference angle? So this is where I would urge you guys to be drawing your bow ties, right? This bow tie would come up to the x-axis, and that should make a right angle. The reference angle is the size of this angle. So what we're always doing is we're finding the distance from that terminal side to the x-axis, or not the distance, but the amount of rotation. So if this is 280, and I want to know how much more I'd have to rotate to get to 360, I'm just going to do 360 minus 280, and so that reference angle is 80 degrees. Remember that you're always going to the x-axis. All right, let's look at this next one. So negative 120, so I know it's negative, so here's my initial side, and then I'm going to be rotating clockwise because it's a negative angle of rotation. 120 is less than 180, so I would be in that quadrant. So this right here would be a negative 120. Now, how big would my reference angle be? I'm going to draw the part of the bow tie going to the x-axis. There is my mark there. And this is the angle I'm looking for. So if I had gone all the way around to here, that would have been 180. This is only 120. So if I do 180 minus 120, that reference angle is 60 degrees. And we terminate in the third quadrant. All right, let's look at some that are in radians. So negative 7 pi over 4. Let's say we start with this. Now remember, you can think about this in terms of radians or in terms of degrees. If you're thinking about this in terms of radians, and I'll go back to degrees in a second, but I know that this is negative, so my initial side is here, and this is going to swap around and go that way, right? Now let's think about 7 over 4, because really this is equal to negative 7 over 4 pi. That is negative 1 3/4 pi. So this is between 1 pi and 2 pi, but closer to 2 pi. So negative 1 pi would be 180. Negative 2 pi would be 360. So this is going to terminate in quadrant 1. It's going to be 1 and then 3/4 more pi around your circle. Now, my reference angle when you work in terms of radians is pretty easy, because if that's pi over 4, then your reference angle is just pi over 4. Now, let's say that we panicked and we really just weren't sure how to think through that with fractions. What you can always do with a radian is take it and convert it to degrees. So negative 7 pi over 4, that's a radian, right? I want to convert that to degrees, so I'm going to put radians in the denominator, degrees in the numerator, and I'm going to have 180 on the top and pi on the bottom. Remember that that fraction is on your reference sheet, so you don't need that memorized. So the radians cancel because they're units, units cancel. The pi's cancel because they're being divided, so those cancel. So what I'm left with is negative 7 times 180 over 4, and that is negative 315 degrees. So that would also terminate here in quadrant 1, and my reference angle there would be 360 minus 315, which is 45 degrees. So remember, whether you're in radians or degrees, you can think through these the same way. You can always convert to degrees and figure out from there. Okay, let's do some actual problems where we're solving for some stuff. So these problems, I will tell you, show up all the time on the Regents. If I had to say like the most asked trig problems, it's questions like this where you're given a sine, a cosine, or a tangent, and you're asked to determine some other information about them. So we're going to look at two different ways to do that. So first way we're going to do it is by actually drawing some triangles. And the second way we'll talk about doing it is using the Pythagorean identity, which is the fact that sine squared plus cos squared is 1. So let's do the first few of these by drawing some triangles. So given an angle that terminates in quadrant 2, so first thing I'm going to think about is that's in quadrant 2, right? There's my little reference triangle. Find cosine and tangent. And before I do anything, I'm going to think about the signs of these. Cosine in quadrant 2 should be negative. And that's because if we think ASTC, right, all students take calculus. In quadrant 2, sine is positive. Also, in quadrant 2, the x-coordinate would be negative. So cos is negative. And tangent should also be negative. So both of these answers should come out to be negative. And it tells me that sine is 1/3. So let's label what we can on this picture. This would be my reference angle. Sine is 1/3. So sine, since it's opposite over hypotenuse, this would be 1, and that would be 3. And so I need to figure out that side to be able to figure out these other things. So I'm going to use the Pythagorean Theorem, which says 1 squared plus x squared is 3 squared. So x squared is 8, right? 9 minus 1. And so x equals radical 8, which we also know is 2 radical 2. Because remember, 8 is 4 times 2. So that is this length over here. Okay, now if I wanted to find cosine, first of all, I know it should be negative, right? And I'm going to do the adjacent, which is 2 radical 2, over the hypotenuse, which is 3. So again, I'm taking the adjacent over the hypotenuse, right? And then for tangent, I'm going to do the opposite over the adjacent. And again, I know that should be negative because tan is negative. So those would be my two values for that problem. All right, let's do one more like this, and then we'll actually go and do some using the formula. So terminal ray is drawn in standard position, and it passes through the point -4, -7. So it goes through that point. And I know if I make this triangle that that length would be 4 and that length would be 7, right? So I'm talking about quadrant 3. It wants me to find all 3 trig ratios. So I need to find sine of theta, I need to find tan of theta, and I need to find cos of theta. So let's think about what is positive in this quadrant. ASTC, this is the T quadrant, which means only tangent would be positive here. So sine is going to be negative, cos is going to be negative, tangent is going to be positive. So I'm starting with that for my fractions. Now, I'm going to find this missing side before I go any further. So 4 squared plus 7 squared equals x squared. That's 16 plus 49. So that is, that's 65. And so x would be the square root of 65. So that is that length. So let's figure these out. Here's theta. So to find sine, I'm going to do the opposite over the hypotenuse. So I know that that's negative, so 7 radical 65. To find tangent, I'm going to do opposite over adjacent. So that's positive 7/4. To find cos, I'm going to do adjacent over hypotenuse, which is 4 over radical 65. And notice, again, that sine is negative, cos is negative, but I've got all three values. Okay, so let's try one using the formula. So this is the same scenario, and if you like doing it by drawing the triangle, continue drawing the triangle. I just want to review both ways so that you've seen them. So, given that sine squared plus cos squared is 1, so they're giving you this identity. Sine is negative 4/5. Find cos if theta is in the third quadrant. So I'm going to start by saying if theta is in quadrant 3, cosine should be negative, right? That's the quadrant where tangent is positive, so cosine should be negative in that quadrant. So let's sub in. So sine squared plus, oh, whoops, I was doing it wrong in my head. Sine is actually negative 4/5. So negative 4/5 squared plus cos squared equals 1. Now I'm going to square everything. So this would be 16 over 25 plus cos squared equals 1, right? Subtract 1 over, so I would get cos squared equals 1 minus 16 over 25, which is 9 over 25. And then square root both sides, which for this just means square root the top and square root the bottom, and that's 3 over 5. Now remember, we want our answer to be negative, so cosine of theta is negative 3/5. So that's just another way to do it if you like using the formula better. It's totally up to you what you prefer. I personally think when in doubt, draw it out as a triangle. Okay, so next thing let's look at is a little bit more practice with converting between degrees and radians, because that's going to be something that's a skill that comes up a lot as we do some of these other things. So next thing I want to look at is these. These two conversion factors you do not need to memorize. They're on your reference table. You just need to know which to use when. So remember that our goal is to be able to cancel units. So let's pick one of these to start on. So if I start with, let's say 31, this is degrees, right? So 31 degrees, I want degrees to cancel, so I'm going to multiply by something with degrees on the bottom, and I want radians to be my answer, so that's going to be on the top. Now, this, I'm going to look at these and say which goes where. If I want radians on the top, I'm going to need to use that one. So you don't need to memorize like this is what I do when. You just need to think about what do I want to cancel. Pi radians will go on the top, 180 will go on the bottom, right? And so this is really 31 over 1. Here, your degrees cancel out, and so this is 31 pi over 180 radians. Now, if that reduces, wonderful, reduce it down. If it doesn't reduce, wonderful, leave it alone. That's as far as that one can go. All right, let's do one more of these. So 360 degrees, hopefully you already know what that is, right? But what I would say is, okay, 360 degrees. I want degrees to cancel, so it goes on the bottom. Radians goes on the top. So pi radians, 180 degrees. And the degrees can cancel. This is really just over 1. So this is 360 pi over 180. 360 over 180 is 2, so that is 2 pi radians. Now, what if we go the other way? So going the other way, now I'm giving you something in radians. I want to go to degrees. So here I have pi over 8, and the radians is the unit, so I'm writing it right there. Now, I want radians to cancel, so I'm going to put that in the denominator. Degrees is going to go on the top. So now you need the 180 on the top because that's where the degrees are. Pi will go on the bottom because that's where the radians are. So radians cancel, pi's cancel. And so what I really get here is 180 over 8. which is 22.5 degrees. Let's do one more where, let's see, these all have it. Let's try negative 2 pi over 3. So this is in radians, negative 2 pi over 3. Radians will go on the bottom, degrees will go on the top, and I want 180 on the top, pi on the bottom. So let's see what cancels. Radians cancel, pi cancels. So this is negative 360 over 3, and so that is negative 120 degrees. Okay, so now let's talk a bit about coterminal angles. Coterminal angles are angles that end in the same spot. So if I have this angle right here, maybe that's 135 degrees. If I go around another 360 degrees, I'm still back to where I started, right? So to find coterminal angles in degrees, we just add or subtract 360. To find coterminal angles in radians, we can just add or subtract 2 pi. So let's look at one of these. So let's say I start with negative 60 degrees. So if I wanted to find, I could add 360, right? So 300 degrees would be coterminal with that. If I wanted to find another one, I could add 360 again, right? And I could keep doing this. 660 would be coterminal with that. I could also subtract 360, and that would be negative 420 degrees. That would be coterminal. So any of these angles, negative 60, 300, 660, negative 420, those all are separated by 360 degrees, which means they terminate in the same place, okay? Now, if you're doing it in radians, what you're going to want to think about is adding 2 pi. So let's say I start with pi over 8. I want to add 2 pi radians. What you can do in your calculator is just do 1/8 plus 2 and then just multiply that answer by pi. So 1/8 plus 2 would be 17 over 8 and then multiply by pi, so 17 pi over 8. It would also work the other way if you subtracted 2 pi. And so that would be 1/8 minus 2 times pi, which would be negative 15 over 8 pi. Now, you also could convert that to degrees and get your answer that way. The only problem is if it wants an answer in radians, you may need to convert back. Okay, reference angles we've already touched on briefly. Remember that it is just the angle between that terminal side and the x-axis. So for instance, 312 degrees, that's in this quadrant. So if you were going to make an angle with the x-axis, you'd be looking for this. So you would be doing 360 minus 312, which is 48 degrees. Now, one thing I will tell you, reference angles do not need to be 30, 45, or 60. They do, however, need to be acute. They have to be less than 90. Now, with radians, you can always convert that into degrees, but here's a fun trick. If it's over 3, your reference angle is pi over 3, which is 60 degrees, right? So same thing with that one, pi over 3. If it's over 4, your reference angle is pi over 4, which is 45 degrees. And if it's over 6, your reference angle is pi over 6, which is 30 degrees. But remember, you can always convert. Okay, last thing we're really going to talk about, and then we're going into graphs, is finding exact trig values. So this chart, remember that you need memorized. It's sine over cos, y goes to the sky, and then 30, 45, 60. So 1, 2, 3, 3, 2, 1. All of these are over 2. Square root the tops, and remember that the square root of 1 is 1, so it's okay if you leave it off those. And then tangent, it's radical 3 over 3, 1, and radical 3. So make sure you know that chart. Now, if you need help finding your exact trig values, the steps are right there for what you should be doing. But we're going to actually go through and find some. So let's say that I want to find sine of 210. So sine of 210, first let's think about where that is. That is in the third quadrant. And let's find our reference angle. So this is my reference angle, and I'm talking about the angle in here, the angle between 210 and 180. So your reference angle here is 30 degrees. So I know that this will be equivalent to sine of 30. What I need to know is, will it be positive or negative? So in this quadrant, remember you have A, S, T, C. So that quadrant tangent is positive, which means this will be negative. So now all I need to do is go up to my chart. Sine of 30 is 1/2. And so this will be negative 1/2. All right, let's do another one. Let's try tan 120. So what quadrant are we in here? That is in quadrant 2. The reference angle here is this angle, which would be the angle going to 180. And to get there, we would have to go 60 more degrees, right? 180 minus 120 is 60. So to figure this out, I know this will be equivalent to tan 60. Let's just think about in that quadrant whether it should be positive or negative. So A, S, T, C, sine is positive, so this will be the negative tangent of 60. And tangent of 60 is radical 3. So that's your solution. All right, now let's say that we had a quadrantal angle. Do we have any of those here? We don't have any in here. All right, we're going to do a quadrantal angle. I'm going to make one up. Let's say that I gave you sine of 180, right? So that's not technically on my table. So what you need to think about with a quadrantal angle is 180 degrees is over here. The coordinate of that is -1, 0. And remember that sine is your y value, right? So the y value there is 0, which means sine of 180 is 0. Now I asked you for tan 180. Remember that tan is y over x. So I'm just taking that same coordinate point, doing y over x or sine over cos, and that's 0. If you're unsure whether it's 0 or undefined, put it into your calculator. All right, now what if they gave it to us in radians? So if they gave it to us in radians, the easiest way for most people is to just convert it to degrees. So for, in this case, 3 pi over 4 is 135 degrees. And then you would be saying, okay, what's my reference angle? That's here. Reference angle is 45. And in that quadrant, cosine's negative. So this would be negative radical 2 over 2. But you also here could say it's over 4, which means the reference angle is pi over 4. And then just figure out what quadrant you're in, and it will work the same way. So that is another case where that would work. Okay, so let's leave that there and let's start to look at some graphing. So important things to know about equations of sine and cosine. Y equals A sine bx plus c. The important things I'm looking at here are A, which is my amplitude, B, which is the frequency, and C, which is the midline. Now remember, to get the period, that would be 2 pi over your B value. So let's look at a couple of these. So on this one, I want the amplitude and I want the period. Remember that there is an unwritten 1 out here, so the amplitude of this curve would be 1. Now the frequency here is 4, which means from 0 to 2 pi we would fit 4 curves. So the period is going to be 2 pi over 4, which is pi over 2. And hopefully that makes sense. If what I'm saying is from 0 to 2 pi, I'm fitting 4 full curves, right? So 1 full curve, 2 full curve, 3 full curves, 4 full curves. Then if that is 2 pi, I'm breaking it up into 4 parts. Each one would have to be half a pi. So this is my amplitude, and that is the period. All right, let's do one more of these. Let's do number 6. So y equals 3 sine 2/3 x. So amplitude here is 3. So I know that from the midline to the top would be 3. The frequency is 2/3. So from 0 to 2 pi, I can fit 2/3 of a curve. And so the period would be 2 pi over 2/3. And what you need to be able to do there is say, okay, that's 2 pi times 3 over 2, which is, remember that's just over 1, 6 pi over 2, which is 3 pi. Now if you wanted to do that on your calculator, what you would do is 2 over 2/3 and then just multiply that answer by pi. Okay, let's do this from some graphs. So I want to find amplitude and period, and then try to write an equation. So on number 7, let's look at this. Your midline's at 0. So the amplitude here is the distance from the center to the top, and that is 3. So A equals 3. Now the period, which is the length of one curve, this is a sine curve. It starts at its midline. It goes up, comes down, and goes back, and it would start repeating right there, right? If I drew another one, that would be an exact repeat. So the length of one of those curves is pi. Okay, the length of one of those curves is pi. So the period here, sorry for that noise, is pi. But what is the b value? So remember that frequency is 2 pi, or over the period, which is 2. Now the other way you could figure that out is by looking from 0 to 2 pi and seeing that there are 2 full curves. So this would be y equals 3 sine, because it starts at its midline, 2x. All right, let's try another one of these. So let's look at this one. So first of all, I see this is a cosine curve. So y equals blank cos blank x, and then plus blank, right? We've talked about doing that. On this case, the midline is 0, so you don't need the plus at the end. Now, your amplitude from the center to the top, middle to the top, is 4. So amplitude is 4. And let's look at the period. So cosine curve starts at its max. It's going to go down and come back up in 2 pi. So the period here for one full curve is 2 pi. Now remember that your frequency, and there's 2 ways you can figure it out. The first way is to say, oh, from 0 to 2 pi, there is one full curve. Now the other way you could figure that out, remember, is that frequency is 2 pi over the period. So you could do 2 pi over 2 pi, which tells you that your frequency is just 1. All right, let's do another one of those. Let's go down here. Actually, let's just do some graphing. Let's graph some. Let's jump into this. So we're going to graph these on the interval from negative 2 pi to positive 2 pi. And so let's check out this one. So on this, I look at this. Okay, my amplitude is 4. My frequency is 1, because that's 1 sine, or 1x, right? And so the period is 2 pi over 1, or 2 pi. Now the midline is going to be at y equals 0. So graphing this, I'm going to start with my midline, which is at 0, so that's just your x-axis. And I know that a full curve should go from 0 to 2 pi. So that is my full length there. And notice this one's already 8 boxes for you, but if you had to label this yourself, you could just go out 8 spaces. Now, what do I want to graph? Well, I know it's a sine curve, and sine starts at its midline. And then what's my amplitude? Well, this is going to go up to 4 and down to negative 4, right? And you could label each one of those if you wanted, but make sure I can at least tell what your scale is. And now let's graph. So sine starts at its midline, it goes up to its maximum, comes back down to its midline, goes back to its minimum, and then comes back to there. So that right there is one full curve. Now, that is graphed from 0 to 2 pi. So we need to go backwards also. So I'm just going to repeat these points back here. And notice I don't have arrows on the end because I have a closed interval. Okay, let's do another one. Let's do 13. So y equals 2 sine 2x. So amplitude here is your a value, which is 2. Frequency is your b value, which is 2. Period is 2 pi over your b value, 2 pi over 2, which is just pi. So what that tells me is one curve will go from 0 to pi. And the midline is still y equals 0. So let's start this again. Ready? So midline is still the x-axis. It's a sine curve, so it should start at its midline. It will end back at pi. And so we need to do all 5 of those important points, but shrunk down in a smaller scale, right? So instead of skipping 2 between each, like I did on that top one, I'm going to just skip 1 box. So my max should be at 2, my min should be at -2. And so this would go up to 2, down to 0, down to -2, back to there. So that would be 1 full curve. And now we just need to repeat it. So back up, back down, back up. And remember, your frequency is 2, so it makes sense that there are 2 full curves there. Same thing here. So this would go down, up, down. And then repeat it one more time. And that would be your curve. So let's look at another one. Let's try this one. So y equals negative cos 2x. So the idea with this is that your amplitude here is still 1 because amplitude is a height, right? This just says it's reflected over the x-axis. Your frequency is 2, which means the period is 2 pi over 2, which is just pi, and the midline is still 0. So this is going to have a amplitude of 1 and a midline of 0. Its cosine, which normally starts at its maximum, but since it's flipped, it's going to start at its minimum. And a full curve should take pi radians. So I know it's going to start here. It's going to come back down to its minimum here. And it's going to go 0, maximum, 0, minimum. So it's going to look like that. That would be a flipped over cosine curve, right? And then just repeat that. So you're going to keep repeating that in the amount of space that you have. And you also need to graph on the other side. So that would be like this. It's a little bit easier to connect on paper than on my iPad. All right, let's look at a little bit more interesting one. Let's look at this one. So y equals 3 cos 1/2 x. So amplitude here is 3. Frequency here is 1/2, which is the number of curves. So there'll be half a curve from 0 to 2 pi. Your period is 2 pi over 1/2, which is 2 pi times the reciprocal of 1/2. So that's 4 pi. And midline is still 0. So again, it's going to start at 0. The amplitude will go up 3, down 3, right? So you've got those points to contend with. Now you know that it's only going to do a half a curve from 0 to 2 pi. So this is cosine. Its y-intercept should be at its maximum. And when I get to 2 pi, that should be at its minimum. It should be half a curve. So here, I would make that hit halfway between. So this would be what that looks like. And again, if they didn't label it, you could just go out 4 boxes and label that 4 pi. Here, again, you want half a curve in that space, so you can complete your curve. So if this is something you feel like you still have questions about, come see me. This is something that definitely we can continue to work on, but let's do some where maybe there's some vertical translations too. So this one, y equals 2 sine theta plus 1. So amplitude equals 2, frequency equals 1, which means the period is 2 pi over 1, or 2 pi. And then the midline is at y equals 1, because this is shifted up 1, right? So I'm going to start by putting my midline on here. And I just kind of do a dotted line. And now let's see what we know. So this is sine, so it's going to start from its midline, so that will be here. And I know that the period's 2 pi, so I'm going to count out 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. That will be 2 pi. And I know that the amplitude is 2. So from 1 it will go up 2 and it will go down 2. So this is 3 and that's -1. And so those will be my max and my min. So let's graph what we know. It starts at 0. 2 spaces later, it will go to its max. 2 spaces later, it will go back to 0, or it's not 0, it's midline. It will go back to its min and then back up to its midline. So this is going to look like that. It should look the same as regular 2 sine x. It's just shifted up. Now, it doesn't tell me how much to graph, so you could repeat this pattern over on the left side, right? You could graph it at its minimum, at its midline, at its maximum, and then back at its midline, and just repeat that. But this one does not give you a limited domain, so you should have arrows on the end of this one. All right, let's look at this next one. So y equals cos 2 theta minus 1. So first thing I see, amplitude is 1, right? 1 cos. Frequency is 2. Period is 2 pi over 2, which would just be 1 pi. And the midline is y equals -1. Okay, so here's what I've got. I know that my midline will be at y equals -1. I know from there it should go up 1 and down 1. So 0 and -2 would be your max and your min. The period is 1 pi, so 1, 2, 3, 4, 5, 6, 7, 8. I'm going to label that point pi. That's 1 period. And then every sort of 2 spaces, I'm going to put a dash, and that'll be where my points are. Now, this is a cosine curve, so it should start from its maximum. It'll go to its midline, to its minimum, to its midline, and back to its maximum. So that is what your cosine curve looks like. And again, yours should go perfectly through. It's a little hard on my iPad to draw it. And arrows on the end. Again, you could repeat it on the other side, but that would be 1 full period. Okay, let's do one last one of these. And this is sort of, I would say, the toughest that they're going to get is if you see something like this one. So y equals 2 cos 2 theta minus 3. This has everything all together. So amplitude, 2, right? That A value. Frequency, 2. Period is 2 pi over 2, which is just pi. And midline is y equals -3. So when I graph this, I'm going to start with my line at -3. My amplitude is 2, so the highest I will go is up 2, the lowest I will go is down 2, right? The period is pi, so when I count over 8 spaces, so 2, 4, 6, 8, that will be pi. And you could label these pi over 2, pi over 4, etc. if you wanted. And then what I know is that this is a cosine curve. So cosine should start from its max, go to its midline, go to its min, back to its midline, back to its max. And so that would look like that, right? You could repeat it on the other side. This should have arrows on the end because they don't give us a restricted domain. And that would be what that looks like. Okay, final thing we're going to talk about are some word problems. Okay, sorry for that. I had a little bit recorded and cut out, so I'm just going back. So San Francisco Bay is an inlet of the Pacific Ocean. At the dock, the depth of the water is 3 feet at low tide, and high tide is 71 feet, and that occurs every 5 hours. So we want to draw a graph showing the depth and then write a function. So let's see what we know first. So I know that at midnight, so let's consider this time midnight, time equals 0, that this would be at low tide, right? So it says the water is at low tide at midnight, and that is at 3 feet. So that's going to be 3, okay? High tide is 71 feet, which occurs every 5 hours. So this is 71 feet, and that occurs every 5 hours. So here's what I know. A full cycle will take 5 hours. Now, in this case, it's not starting at high tide. It's starting at low tide. And so what I know is it will be back to low tide in 5 hours. So this is going to be halfway between at 2.5 hours. Okay, because one full cycle is 5. So let's see what we know. So we already know our min and our max. What is this? I'm going to say, is this a sine or a cosine function? So this starts at its minimum, so this is going to be a cos function. And I know that's x plus blank. So if I can just figure out A, B, and C, I'll be good here. So let's start with what we know. We know that that's our min and that's our max. If I want to find the midline, there are two ways you can do it. You can find the distance between those, divide it by 2, and then add or subtract from the bottom. Or you can average them, and that will also give you your midline. So 74 over 2 is 37. So your midline here would be at 37. So this is 37. Now, think about what that means for your amplitude from the center to the top there, right? So from 37 to 41, that is going to be 34 there. This is a cosine curve that starts at its minimum, so that will be negative out front. And then I know that my period is 5, so the frequency will be 2 pi over 5. And I can't reduce that, so that is your B value. So that's what I have there. There's my graph. And then I've got negative because it starts at its minimum, 34 because that's distance from the middle to the top, 37 because that's your midline, and 2 pi over 5 because that's 2 pi over the period of the whole thing. Okay, you go to the carnival and decide to ride the Ferris wheel. The wheel is 3 feet off the ground and the diameter is 38. So let's see what I've got there. This is 3 feet, and then the diameter of the wheel is 38. So let's think about where that leaves us, thinking about sketching this graph. So the minimum here would be at 3. The maximum, well, 38 plus 3 would be at 41, right? And it takes us 4 seconds to reach the top. This is the world's fastest Ferris wheel. So it takes us 4 seconds to go from there to there. So the period of this Ferris wheel is 8 seconds, right? To go all the way around would be 8 seconds. So that should not be 10. We're going to ignore that for now. So if it takes you 4 seconds to reach the top, and it's going to take us 8 seconds to get all the way around. So let's draw a graph and write a function. So we get on the bottom. We are going to go up in 4 seconds and then come back down, and that will take us 8, right? So that's my cycle there. So I know this is y equals blank. Now sine or cos, this starts at its minimum, so cos blank x plus blank. Let's see what we know. So first of all, I know that the period is 8 seconds. So the frequency is going to be 2 pi over 8, which is pi over 4. So that's going to go in there. Now, the period, I'm sorry, we have the period and the frequency. The midline is going to be halfway between those. So again, you can find the distance between, cut it in half and add it, or you can average these. So 41 plus 3 over 2, which would be 22. So that's your midline. And then what is your actual amplitude? So that's the distance from the center to the top. And actually, if you think about the wheel, the distance from the center to the top is 19. That's also the distance from the center to the top here. So that's 19. Because it starts at its minimum, it's going to be negative, and that is my curve. Okay, so that's really the key to what you guys will want to be able to do for this test. If you have more questions, if you want to see more of something, send me a message. But hopefully, going through these examples, going through all of this stuff, and just you doing some practice will help. The reason why I didn't do every single problem is I want you to be able to try them on your own as well. So we have done the first two. Try the last one. If you still have questions, send them to me. And good luck, guys. You're going to do great. I will see you later.